In section 6.1, we look at solving trigonometric equations. And I have 4 examples of trigonometric equations on the screen here. And what we'll be doing is solving for the values of the variable, which may be x or theta or some other variable, for which the equation is true. So if you look at an equation like the first one here, we want to know what values of x, what angles can we plug into this equation to make the left side of the equation be the same as the right side of the equation. And the same thing is true for all of these. That's what we're trying to do. So in order to do this, we need to start with a little review from algebra. So in our first example, let's consider the simple algebraic equation 5x plus 7 equals 2x minus 5, and we're asked to solve for x. So we need to remember some very basic principles for solving equations. First of all, this type of equation is a linear equation because the variable is only raised to the first power. So when you have this kind of equation, what you typically want to do is gather all the terms that have variables on one side of the equation and all the terms that do not have variables on the other side of the equation. So you can see we have a 5x on the left side and a 2x on the right side. So if we subtract 2x from both sides of the equation, on the left-hand side, 5x minus 2x is 3x. The positive 7 still comes down. And on the left-hand side, positive 2x minus 2x cancels out, and so we just have negative 5 left over. Now we can get the x term completely isolated if we get rid of the positive 7 here. And we can do this by subtracting 7 from both sides of the equation. And in doing this, we get 3x, cancellation here, and then equals negative 5 minus 7 is negative 12. And finally, to solve for x, we can divide both sides by 3 in order to cancel the 3 here, and we end up getting x is equal to negative 4. So I will expect that you remember your addition and subtraction and multiplication and division properties of equality, meaning that you can add, subtract, multiply, and divide the same number to both sides of the equation. Now let's take a look at a trigonometric example. So in our first example, we have 2 times sine of x minus 1 equals 0, and we wish to solve for x. So in this case, the first thing we need to do is isolate not the x, but rather the trig function that has the variable in it. So we want to get sine of x by itself. We can accomplish this by adding 1 to both sides of the equation. And that gives us 2 sine of x is equal to 1. And then we can divide both sides of the equation by 2. And that gives us sine of x is equal to 1/2. Now from here, it becomes a problem of trigonometry. We want to know for what angles x is the sine of x equal to 1/2. Now, there are several different ways you can approach solving this equation. What I like to do is remind myself that sine is positive in the first and second quadrants. And that means if sine of x is equal to 1/2, the angle x has to either be in the first quadrant or it has to be in the second quadrant. And so what I can do then is construct a diagram showing what that angle might look like by drawing a reference triangle. So here I have a reference triangle in the first quadrant, and here I have one in the second quadrant. And what I know about this angle, which is x, is the sine of that angle is opposite over hypotenuse. So this is 1 over 2. Likewise, for this angle over here, sine of it is also opposite over hypotenuse, 1 over 2. And then we can solve for the missing side of the triangle. Although we are not looking for the side, we want to know the angle, but if we find the missing side, that will help us determine the angle. So if you find the missing side here, you'll find that it is radical 3, and the missing side over here is negative radical 3. And so you should recognize that this triangle is a 30, 60, 90 triangle. So the angle inside here is 30 degrees. Likewise, in the other triangle, this angle is 30 degrees. And that means that the angle that we are looking for, which is this angle here, is 180 degrees minus 30 degrees, which is 150 degrees. So without too much trouble, we can see that the solution is either 30 degrees or 150 degrees. And this would be the solution if they asked for the solution in degrees, where x is an angle between 0 and 360 degrees. Sometimes they'll ask for the answer in radians. If they ask for this answer in radians, we would simply say that x is pi over 6 or 5 pi over 6, because those are the direct conversions of 30 degrees and 150 degrees to radians. And this would be the solution if they asked for the solution in radians, where the answer has to be between 0 and 2 pi. However, sometimes they will ask for all degree solutions or all radian solutions. If they ask for all degree solutions, what we do is we take these two solutions, which are our fundamental solutions, and then we just have to recognize that if you take an angle like 30 degrees, and if you add multiples of 360 degrees to it, you will end up at the same angle. So if we were to give all degree solutions for this equation, we would say x is equal to 30 degrees plus 360 degrees multiplied by k, where k is equal to some integer. And again, all we're doing here is we're adding revolutions to the angle 30 degrees. So we can add as many multiples of 360 degrees as we want, or subtract 360 degrees, and we will end up in the same spot. So in other words, these are all the coterminal angles with 30 degrees. And then the other solution, of course, would be 150 degrees plus 360 degrees times k, where once again, k is an integer. So this is how you would give all of your solutions if they asked for them to be in degrees. If they ask for all the solutions in radians, then you basically do the same thing except that you use radians instead of degrees. So all the solutions in radians would be x equals pi over 6, that's this solution here, plus, and now instead of saying 360 degrees times k, we would say 2 pi times k. And the other answer would be 5 pi over 6 plus 2 pi times k. And once again, for both of these, k would be equal to an integer. So you have to pay attention to how they ask for the solutions. Now, this is all semantics. The important thing is how you get these solutions in the first place. So the fundamental principle of solving a trig equation is that you want to get the trig function by itself and then determine the angles by drawing a simple diagram. Let's take a look at some other examples. In this example, they ask us to find all values of x for which 2 cosine of x minus radical 3 equals 0 if x is an angle between 0 and 360 degrees. So this tells us they want the answer in degrees. And so we just need to take the equation and solve for x. So first we're going to get cosine of x by itself. We could do this by adding radical 3 to both sides. This gives us 2 cosine of x is equal to the square root of 3. And then dividing both sides by 2, we end up getting cosine of x is equal to square root of 3 divided by 2. Now I need to find what angles between 0 and 360 is cosine equal to radical 3 over 2. So first of all, we know that cosine is positive in the first quadrant and the fourth quadrant. So if I want to draw a picture of what this angle might look like, I will have a reference triangle in the first quadrant, and I'll have a reference triangle in the fourth quadrant. And these triangles are exactly the same shape because cosine is the same value for both of these angles here. So this angle is x, and this angle is also x. So we have 2 possibilities. We know that cosine is the adjacent side divided by the hypotenuse. So that means that this side here is radical 3, and the hypotenuse is 2. And here, if you find the missing side, once again, this missing side here will be 1, and over here it will be negative 1. And this confirms that we once again have a 30, 60, 90 triangle. And so now we know that this angle in here must be 30 degrees, and this angle in here must also be 30 degrees. So what are the angles for which this is true? Well, one angle is 30 degrees, right? Because in standard position from here to here is 30 degrees. So that's one possible solution. The other possible solution is this angle over here. So the way we can compute this angle is that if we know that if we go all the way around to here, that is 360 degrees. And then if we subtract 30 from that, we will be at 330 degrees. So our 2 solutions here are 30 degrees or 330 degrees. And that's all we need to do because that's all they asked for in this problem. In the next example, we have 2 sine of theta minus 3 is equal to 0. And they want us to solve for theta, where theta is once again an angle between 0 degrees and 360 degrees. So we go through the same steps. I will add 3 to both sides. And this gives us 2 sine of theta is equal to 3. And then we could divide both sides by 2. And we have sine of theta is equal to 3/2. Now, these numbers don't really look familiar, but let's think about where this would occur. So once again, we know that sine is positive in the first and second quadrant. So if we're going to have solutions, that's where they'll have to be. So I will draw a reference triangle in each quadrant. And we know that sine is the opposite side divided by the hypotenuse. Now, if you look at this carefully, this doesn't make any sense, right? Because for sine to equal 3 over 2, it means that the leg here has to be longer than the hypotenuse. And this is not possible in a right triangle because we know the hypotenuse is the longest side. So right away, we know that this is not possible. And that means that this equation has no solution. Now, suppose you don't see this and you still want to try to find this angle. It's possible that you may not recognize that we have a problem. What you would do is you would try to find the reference angle theta hat. And you would do this by saying sine of theta hat is equal to 3 over 2. And that means that theta hat would be the inverse sine of 3 over 2. And if you plug this into your calculator, you will get an error. And again, the reason you get an error is because this is not possible. So no matter how you try to solve this, at some point you have to realize that this is not possible to solve. So the answer here is no solution. In our next example, it's a little bit more complicated. We have 3 times sine of theta minus 2 equals 7 sine of theta minus 1. And again, we're solving for theta, where theta is an angle between 0 and 360 degrees. And so the first thing I'd like to do is get all of our sine of thetas on one side of the equation. And it doesn't matter which side you choose, although many students prefer the left-hand side, so that's what I will do here. So I will subtract 7 sine of theta from both sides of the equation. Doing this gives us -4 sine of theta minus 2 equals -1. And then I can add 2 to both sides of the equation. And adding 2 gives us -4 sine of theta is equal to +1. And now finally we can get sine of theta by itself by dividing by -4. And this gives us sine of theta is equal to -1/4. Now we need to think about where will this occur. What are the angles for which sine is equal to -1/4? Well, again, we know that sine is negative in the third quadrant and the fourth quadrant. So if I draw a diagram of the angles, they would either have to be in the third quadrant or in the fourth quadrant. And we also know that sine is opposite over hypotenuse. So if this is my angle here, sine would have to be the opposite side divided by the hypotenuse. And if this is my angle here, sine would once again be the opposite side divided by the hypotenuse. Now, these triangles are not special. What I mean is, these are not special angles. So how do we determine what these angles are? Well, once again, we have to lean on reference angle. So I'm going to call this angle here theta hat. This angle over here is also theta hat. And we know from the reference angle theorem that the sine of theta hat would have to be +1/4. So remember when we learned about reference angles, a trig function of a reference angle is the same as the trig function of the angle, but when you're talking about the reference angle, it can never be negative. So we have -1/4 up here, but when we talk about the reference angle, it must be +1/4. So we can solve for theta hat now by simply taking the inverse sine of 1/4, and now we have to plug that into a calculator, and we'll round our answer. And the answer I get is 14.5 degrees. And again, this is an approximate answer. So that's the reference angle. But we don't want the reference angle, we want theta. And theta has to be an angle between 0 and 360 degrees. So if you look at your diagram once again, you'll notice that theta is this angle. So to get theta, I need to take the angle 180 and then add theta hat to it. So theta is 180 plus theta hat. And then the other possibility for theta is this angle. And to get this angle, I will take 360 degrees and I will subtract theta hat. So the concept here is that theta is either equal to 180 plus the reference angle, or theta is equal to 360 minus the reference angle. And again, you can see this in the picture. So one value of theta will be 180 plus 14.5 degrees, and this is 194.5 degrees. And the other possibility is 360 degrees minus 14.5 degrees, and this is 345.5 degrees. And so these are the two approximate solutions for this equation. Before we move on to solving more examples of trig equations, let's remember how to solve a quadratic equation in algebra. So a quadratic equation is an equation where the variable is squared. So here we have 2x squared minus 9x is equal to 5. And what you should remember about quadratic equations from algebra is that you want to set equal to 0. So to do this, I will subtract 5 from both sides of the equation. This gives us 2x squared minus 9x minus 5 equals 0. And now to solve these equations, we typically use factoring. But we could also use the quadratic formula. In this problem, I'm just going to use factoring because the factoring here is not terribly difficult. So to get 2x squared, we need to multiply 2x times x. And to get 5, we either need to multiply 1 times 5 or 5 times 1. The combination that works is 1 times 5, and we need a positive 1 and a negative 5. And you can pause to verify that this factorization is correct. And if you're completely lost about factoring, you should watch a video on factoring. Once we have it factored, then we can use the zero factor property, which basically says now you take each factor and you set each one equal to 0 separately. And then you can solve these equations for x. So solving for x in the first equation, we get negative 1/2. And solving for x in the second equation, we get x equals 5. So this equation has two solutions. By the way, the other method involves the quadratic formula. And just as a reminder, the quadratic formula tells you that if you're trying to solve the equation ax squared plus bx plus c equals 0, there is a formula to solve for x, and it says x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So this will be worth remembering, and one of our examples at the end will use the quadratic formula. Now let's do a problem involving trigonometry. So in this problem, we're asked to solve the equation 2 cosine squared of t minus 9 cosine of t is equal to 5. And this time we're looking for t between 0 and 2 pi. That means that in this problem, we want the solution to be in radians. So if you look at this equation carefully, this resembles the equation that we had in the last example. Notice that this is a quadratic equation in cosine of t, because here the cosine of t is squared. So to solve this, I want to set it equal to 0, and I can do that by subtracting 5 from both sides. This gives us 2 cosine squared of t minus 9 cosine of t minus 5 equals 0. And now we can solve this by factoring this expression. And again, if you look at the numbers here, these are the same numbers that we just did in the previous problem. But instead of having a variable like x, our variable here is cosine of t. So when we go to factor it, we're going to have 2 cosine of t here and 1 cosine of t here. And that's because when you multiply these together, you get 2 cosine squared. And in the second spot, we will have 1 and 5, and the 1 will be positive and the 5 will be negative. And you can double check this by multiplying it out, but if you multiply it out, you do get this quadratic. So from here, we take each one of these factors independently and set them equal to 0. And then we can solve for cosine of t, once again, by going through the same steps. Dividing by 2, we end up getting cosine of t equals negative 1/2. And then for the second one, if we add 5 to both sides, we get cosine of t is equal to 5. And now we have to figure out what angles make these two equations true. Well, the second one is actually really simple because it is not possible for cosine of t to be equal to 5. Now, if you're struggling to understand why, just remember that if you have some triangle and t is your angle, if cosine of t is equal to 5, you're saying that it's 5 over 1. And that means the adjacent side is 5 and the hypotenuse is 1. This can't happen, right? This is not possible because the hypotenuse has to be longer than the leg. So this gives you no solution. However, we still have to solve the other equation. So where is cosine of t equal to negative 1/2? Well, once again, we know that cosine is negative in the second quadrant and the third quadrant. And so if we're going to draw a picture of the angle here, we know that it has to be a triangle here or a triangle here. And we know that cosine is the adjacent side divided by the hypotenuse. And so this is what that triangle will look like. And if you solve for the missing side here, you will get radical 3 here and negative radical 3 here. And that means that we have a 30, 60, 90 triangle. So you should recognize these numbers, right? This is a 30, 60, 90 triangle. And so that means that this angle down here is 60 degrees, and this angle here is 60 degrees. But 60 is not the answer. The answer is the angle in standard position. So one of the angles is this angle, and the other angle is this angle. So one possibility for t is 180 degrees minus 60 degrees, right? That's this first one. So you go to 180, and then you subtract 60 to get to here. And that is 120 degrees. Or the other answer is 180 degrees plus 60 degrees, which is 240 degrees. And that's simply because to get this angle, we go to 180 and then we add 60 to it. And so these are the two solutions. However, you need to remember that they asked us to solve this problem in radians. So it's not a big deal, but at the end, what you need to do is you need to convert these answers into radians by simply multiplying by pi over 180. And when you do that, the first angle you get is 2 pi over 3, and the second angle is 4 pi over 3. So those are our two solutions for this problem. In our last problem, we were asked to solve the equation 2 sine squared of theta plus 2 sine of theta minus 1 equals 0. And this time theta is in degrees. And you can play around with this for a little bit, but this is not factorable. So because it's not factorable, we have to use the quadratic formula. Now we had the quadratic formula on the previous page. And we're going to use this to get the solutions here. However, when you use the quadratic formula in algebra, your variable is x. And so when you use the quadratic formula, you are solving directly for that variable. In this equation, our variable is theta, but it's not just theta all by itself. It's sine of theta and sine squared of theta. So when you use the quadratic formula to solve this, you are not solving directly for the variable. You are solving for sine of theta. And so if I go ahead and apply the quadratic formula to this problem, let's just notice that A is 2, B is also 2, and C is negative 1. And I'm going to plug those numbers into the quadratic formula. So when I do that, I get negative 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 1, all divided by 2 times 2. And if we simplify, this is negative 2 plus or minus the square root of 4 plus 8, all divided by 4. So I'm just doing the math in here. Simplifying further, this is negative 2 plus or minus the square root of 12 divided by 4. And we can reduce this to say negative 2 plus or minus 2 radical 3 divided by 4. And if we cancel the common factor of 2 in the top and the bottom, we get negative 1 plus or minus radical 3 divided by 2. Now you need to remember that it is sine of theta that is equal to these values. So one possibility is sine of theta equals negative 1 plus the square root of 3 divided by 2. Or the other possibility is sine of theta equals negative 1 minus the square root of 3 divided by 2. Now these are certainly not special angles. So what I'm going to do is plug each of these into a calculator. And in doing so, we get sine of theta either equals positive 0.3660 or sine of theta equals negative 1.3660. This one here is not possible. So one thing to remember about sine and cosine is they can never be greater than 1 or less than negative 1. So remember, the value for sine always has to be a number in between 1 and negative 1. So if ever you get a value that is outside of this, it's not possible. So we can save some time by recognizing that. However, this one is possible because 0.3660 is a number between 1 and negative 1. So again, the question is, where is this going to happen? Well, sine is positive in the first and second quadrant. So where this is going to happen is here or here. Now, I won't bother trying to label the sides of this triangle because we know this triangle is not special. We can tell that from the value that we have here. So instead, I'm just going to find the reference angle, theta hat, and we can do this by knowing that the sine of theta hat is 0.3660. So theta hat is the inverse sine of this value. And if you plug this into a calculator and round it to 1 decimal place, you get 21.5 degrees. So that means that this angle here is 21.5 degrees, and this angle here is 21.5 degrees. So as for the values of theta, one value of theta is 21.5 degrees. The other value of theta is this value. And to get that one, we take 180 and we subtract 21.5 degrees. And if you do that, you get 158.5 degrees. So our two possible solutions are 21.5 degrees and 158.5 degrees.